Okay, so today in our lesson 3.4, there really are two kind of like main objectives. One of them is how do you graph a function when you're given a distinct domain. They give you distinct x values in set notation, in those fancy graphics. They say, okay, here's your domain. What do we do with that kind of a graph versus what do we do when they don't give us a distinct domain? They don't state what it is, and it really then is all real numbers. Okay, so but we got to show the difference between graphing those types. So in this first one, it says graph each function for the given domain. That's actually only numbers 1 and 2 where they actually give us a domain. We have y equals x plus 2. We would say this is already in what we call function rule form. It's the y is set equal to the function rule, so we should be able to get the y value by just subbing in x values and getting the range value that goes with that domain value. And see, they give us a distinct domain here. So what we're going to do is we're going to find the range, and we're going to evaluate using those 5 x values. So we'll just put those in the x column of our table, because we'll show getting our y values in table form here. Now, if they give us the domain values, they say here in set notation, these are your domain values. That means it is a discrete graph. So the first thing you might want to do is decide, should I have a discrete or a continuous graph? And if it's a discrete graph, we don't connect the dots, do we? We don't connect the points. We just have points on our graph is all. So this one is going to be discrete because they distinctly said we want 5 ordered pairs, and here are the x values for each of those 5 ordered pairs. You need to find the y value for them, okay? So we're going to substitute into our function rule, and that's what we're going to do in this column. -2 plus 2 says take the x value, add 2 to it, and you will get your y value. So what's our y value when x is -2? 0. So that gives us ordered pair what? -2, 0. Okay? And we just keep doing that until we have all of our y values. So putting the x value in, adding 2 to it, and getting our y value. Writing the ordered pair. And typically what will happen is you will see most likely a pattern developing. Anybody see a pattern happening here? Okay, what's happening? The y's just keep going up by 1. The x's are going up by 1 though too, aren't they? There's actually a pattern going on in the x's. As the x's go up by 1, it just so happens that the y's are also going up by 1. So, but we're not going to be careful. You guys are not experts yet at this functions and graphing them. So you need to show work for at least 4 of them to make sure that there's a distinct pattern going on here. And when I do the 4th one, I see, you know what? Yeah, it's not going to change. The y's keep going up by 1s, don't they? So we predict this last point would be what? 2, 4. Okay. Anybody do the work in their table for that one already? Did you get 4? Did you get 4? Okay, awesome. Okay, let's graph those points. -2, 0. I get to assume you know how to graph on an coordinate plane. By the time you get to me, that's what you're supposed to know. You do, right? Okay. -1, 1, 0, 2, 1, 3, and 2, 4. Okay, should we connect the dots?
No.
No, because we have a discrete graph, right? Okay. And then the only thing we have left to do, even if it doesn't tell us to do all these things in our homework, these are all the things we're going to do. We're going to decide, okay, first of all, should I have a discrete or continuous graph? And then let's get the ordered pairs that'll help me make the graph them, and then let's state the range. Okay, what is the range for this one?
0, 1, 2, 3, 4.
Okay, 0, 1, 2, 3, 4. So there's a distinct range also, isn't there? There are 5 different y values to go with those 5 x values. Okay, anybody got questions on that one? It's a pretty basic one. Okay, well let's move on to the next one. Number 2, we have x minus 3y equals negative 6. Is that what we would call function rule form? In other words, is it y by itself set equal to the function rule? Not, is it? So that's the first thing we're going to do is that's what this white space I have here for you is, we're going to get that y by itself so that we have the function rule to write right here. Okay, so let's change it to add the opposite because too many of us have not been successful without doing that with these. So let's just kind of stay there in that habit. Remember, our goal is we're going to get this solved for y. We want y alone. It should be our first move.
Get rid of x.
Get rid of x. How are we going to get rid of x?
Subtract.
Subtract it. Okay, we're going to subtract x from both sides. Now we have negative 3y alone on that side. And we have negative 6 plus negative x. Because I'm going to change it to add the, well, let's not do that right away in this step. Let's just make it the way it is. It's negative 6, take away x. You can't really take x away from 6. You can't combine them, can you? Okay, now I'm going to take that and write it so that I can make it a little friendlier to work with. Negative 6 plus, we can stick a 1 in front of that x, and then we can make that 1 now its opposite because we're changing it to add the opposite. So subtracting x is really the same as adding a negative 1x. Because what are we going to do next? What's our next step? Divide by negative 3. So we're going to divide each piece by negative 3. Remember, when you multiply or divide, you have to do it to every piece. So we end up with, those cancel away. We have y by itself like we want. Negative 6 divided by negative 3? 2. Plus? 1/3 x. 3 doesn't go into 1 nicely, so we write it as a fraction. If the variable's upstairs in a numerator, we can pull it out and put it beside. So 2 plus 1/3 x. There's our function rule. And remember, addition allows us to change things around, so I'm going to make that 1/3 x plus 2. Take 1/3 of x, and then add a 2, and you'll get your y. So the function rule is take 1/3 of x, add 2, you will get y. Okay, now, let's just stop for a moment, though, and look at that, our domain. They gave it to us, didn't they? It says domain in nice set notation. So is this going to be a discrete or a continuous graph?
Discrete.
This is discrete again. So let's write down discrete below our graph to remind ourselves that we will not connect the dots, right? Okay, now we'll put our domain values down in our table and do our substitution. So this is where you're going to have to write a little bit tight, a little bit small, because you're going to have to do some multiplying first, and then you're going to have to do some adding. So I'm just substituting into the function rule. What's 1/3 of negative 6? Negative 2. And then we have that 2 we're supposed to add to that. 0. So negative 2 plus 2 is 0. So we substitute into the function rule, do the multiplication first. 1/3 of negative 6 is negative 2. Add the 2 to it and get 0. So we have ordered pair, negative 6, 0. Okay, go ahead and complete the rest of the table. Because really what you're doing here is just like you did in the homework yesterday, evaluating the function given certain domain values. When do you get to stop and say, okay, there's a pattern that's going on here?
After 4.
After the 4th one. Don't take your chances before that. What's our pattern?
So
Then y's are going up by 1. The x's are going up, are the x's only going up by 1 this time? They're actually going up by 3, aren't they? Yeah, so the x's are going up by 3 as the y's go up by 1. So there is that pattern. So we're thinking x is going to go up by 3. This next one is 6. So we're thinking that the next y value will be what? 4. Okay. So let's graph those ordered pairs. If you haven't yet. Connect the dots? No, it's a discrete graph, so we don't want to connect the dots. One thing left to do, what is it? The range. It's our range this time. So what's our range? Yep. Actually the same range the last one had, right? Okay. So when we have a discrete graph, there should distinctly be a domain where you can name all the x values that are involved and you can name all the y values that are involved. If it's not discrete, you probably can't do that. Okay, any questions on that one? Sometimes you have to get it in function rule form. You're going to get the y by itself set equal to the function rule. But that's the only time we have to do that in our notes. I don't know how many times it happens in your homework, but our next one is in function rule form. Y is by itself. The rule is what? Absolute value of x plus 3. Absolute value of x plus 3. So add 3 to x, take the absolute value of that, and then subtract 2. Yeah, so here's our function rule right here. Is there a domain given to us?
Yes. Yeah.
In set notation?
No.
I know you're looking at these right here and saying, but wait a minute, it says right there. No, I picked those for you. Remember, if it doesn't have a domain given to you in set notation like that, then that means the domain is, what is it?
All real numbers.
All real numbers. It can be any number you want it to be. So write that down. The domain actually for this one is all real numbers. But the reason so when the domain is all real numbers, that means you get to pick whatever you want for x and get some points to make a graph. But at this stage of the game, as ninth graders, typically what you're going to do is you're going to pick some numbers you like. And you don't really like negatives, do you? Probably not so much as positives. So you're going to pick numbers you like, and then you're going to get this graph, and you're going to think, cool, I got it, I did it. And then you're not going to have a very good picture of the graph. So I'm going to, help you along for a while. I'm going to pick your x values for you, for the most part. And so I'm the one who put these in here. I said, you know what, these are going to be good x values to get a good picture of the graph. So this isn't a distinct domain, it's just values that I picked because they didn't give us the domain. So when they don't give us the domain, it's all real numbers. So now we're going to do, and this is really going to get tight, so don't write very big in here. -5 goes in for x, add 3, absolute value bars are around that, take away 2. So what is -5 plus 3? 2. -2. So we end up with the absolute value of -2, and then outside of that, take away 2. What is the absolute value of -2? Positive 2. So now we got 2 take away 2.
0.
And that's 0. It's okay if we get into our other column a little bit. So our ordered pair is? -5, 0. Okay. So now we just carry on, we do it with -4. You notice that first time it's just a substitution step, and then you start, simplifying it down. The next ordered pair I get -4, -1. Agree, disagree? Because negative 4 plus 3 is negative 1, but that's absolute value, right? And what's the absolute value of negative 1? 1. And then we gotta take 2 away from that 1. That'd be negative 1. So don't be fooled into thinking because there's absolute value bars in there, you can't have any negative numbers. No. We have a number, we have something happening outside of those absolute value bars that can end up making it negative. Now, if I were to let you quit right now and only say, oh, there's a pattern going on, I think I know what the next ordered pair is there anybody who hasn't done the next one yet in their table? Has not. You have not done the work yet for when x is equal to negative 2. Or you all have your all so speedy? You haven't, no. Because if I were going to right now, if I were just going to take a guess according to the pattern, as x is going up by 1, so what's happening with y? It's going down by 1. So I'm thinking that, just looking at that pattern, I say, oh, when x is equal to negative 2, I think y is going to be negative 3, according to the pattern, right? Okay. Well, those of you who have done it, what happened? It's not negative 3, it's negative 1, isn't it? So let's put it in there and see why. Negative 2 plus 3 in the absolute value bars. What is negative 2 plus 3? 1. And what is the absolute value of 1? 1. And what is 1 take away 2? Negative 1. See why we got to be careful? We can't always come on those patterns too early. Now you might want to try and make a prediction about it. Isn't going to be ordered pair negative 2, negative 3. We found out it's going to be ordered pair negative 2, negative 1. Now I might want to make a prediction and I see, look at right here what happened. It went 0, negative 1, negative 2, and then it bounced back to negative 1. I'm thinking it's going to, the next one might, the y value might be 0.
0 or negative 2.
So, negative 1, 0. That's what I'm predicting. Did you see the pattern there? Negative 2 is in the middle, then there's negative 1s on each side of it, and then there's 0s on each side. So let's see if that's what happens. Negative 1 plus 3, and then take away that 2. Well, negative 1 plus 3 is positive 2. What's the absolute value of positive 2? 2. So I have 2 take away 2.
0.
And that is 0, isn't it? Okay. Well, we didn't right away in the beginning take time to decide whether this would be discrete or continuous, so let's do that now. Do you think this should be a discrete graph or a continuous? Continuous. Why? Because of the domain. The domain is all real numbers. Can we begin to graph all of the x values? No way. So this is going to be a continuous graph. So after you put your points on there, if they line up nicely in some sort of a straight line, you're going to want to use a straight edge and draw a nice graph. If they don't, then you're just going to freehand it and draw a nice curve. So let's see what happens with this one. Can I get my points on there? They're in, look like they're in a B. How about yours? Is that what yours look like? So okay, wait, now we gotta do a range. A range for this one. The range. Give me an example of, if it can't be all real numbers, then give me an example of a number it can't be. Negative 3. Negative 4. 1. What's the lowest point on that graph? Remember how we did this when we did domain and range? Remember we said, okay, what's the lowest point on the graph? Negative 3, negative 2. So the lowest y value is negative 2. And so remember we have to write this as a compound inequality. So we start with negative 2, the lowest point, is less than or equal to, what goes in the middle? Y, because it's range. And then what's the highest point? Infinite. It's up there somewhere. Remember those, look at those arms, they keep going up and up and up, so we don't know where it's at. So is less than, can we be equal to infinity? No, you can't really get there. So we leave the equal to bar off and we say positive infinity. So the range goes from negative 2 up to positive infinity. Okay. So questions? Are you ready to move on? Okay, we've got one more of these type to do, where we are going to graph it and come up with a range and all that stuff. So look at that. What do you think? Is that, what's the domain for this one? Don't have one. So it's all real numbers then. So domain, all real numbers. Well, if the domain is all real numbers, what kind of a graph should we have? Continuous, which means connect the dots. But notice again, somebody picked your points, your x values for you. And let me show you why. Here's what would have happened on the last one. Let me go back to that last one where I said, you know what, as ninth graders, you guys really like positive numbers. Let me put it onto red here, and I'm going to show you. If you let's say you pick 0 through 4. I say you have to pick 5 x values, and you have to do, and you go, I like 0, and I like all positive numbers, so I'm going to do 0 through 4. Here's the graph you would have gotten. Wouldn't you? Yeah. You would have gotten the same range? No, you would have said the range is what? All real numbers. There's no lowest point, there's no highest point, right? You didn't get to see the turning point because you didn't realize that's what it would do. So that's why, for a while, I picked the points for you because I need you to get a good picture of the graph. And working with the x values I chose gave you a good picture. So I'm doing the same thing back here. I need you to have a good picture of the graph, so I've picked those x values. Okay, so we're going to substitute them into our function rule, which is already ready for us. When you substitute a negative number into an x that's getting taken to a power, you have to use parentheses. Let me say that again. When you put a negative number in and take it to a power, you have to use parentheses. There's just no getting around it. And then, we're supposed to subtract 3 from that. So what is negative 3 times itself? 9. Not negative 9, but positive 9, right? Yeah. And 9 take away 3 is 6. So ordered pair, negative 3, 6. Now, I'm going to suggest that since I gave you more than 5 x values, you probably better roll more than 4 this time. Okay? There's going to be a pattern maybe going through. You might think you're starting to see a pattern, but you're really not when you're only done with 4 of them. So let's see what happens. So go ahead and fill out this table. Get your y values. I'm done with 4 right now, and I'm not seeing, let's see, the x's are going up by 1, but the y's went up by 5, and then it went up by 3, and, or no, it's going down. The y's went down by 5, and then it went down by 3, and then it went down by 1. Oh, there doesn't seem to be a pattern here. So I gotta keep going. Interesting. I got a -2 again. How about you? For when x is equal to 1? Yeah?
Or it changes.
And then when I put 2 in,
It changes.
it goes to 1. Oh, notice what's going on here. Here's
It
the,
changes directions.
yeah, it changes directions. Right here it changed directions. And then it started doing the same thing, but in reverse order, didn't it? -2 and then 1, and now I think I'm ready to predict what I think the last one's going to be. 3, I look here and I see 2, -2, I see the 1s, and then I look there and I say, I think it's going to be 6. But of course, if I'm not sure, I should show work, right? Did you guys get 6?
Mm-hmm.
Okay, awesome, I'm not going to do the work then. Okay, let's grab our points. Okay, it's a continuous graph, so that means we're supposed to connect the dots, right? What happens when you put your ruler through these? Is this a B?
No.
It's not a B.
Weird shape.
It's actually a U. So we're not going to use our straight edge this time. We're going to just draw a nice, smooth curve through. We're going to just say, oh, I just need to, see. Okay. I need to draw a nice, smooth curve. And I'm not going to let the straight edge help me this time, even though it kind of looks like a B, it's really not. Because if you line your ruler up through those points, you're not going to get, it's not going to go through all of them. So you just draw this nice U-shaped graph. Okay, we have one thing left to do, and that is
The range.
the range. So we're going to look and see, okay, what do we think the range is for this one? -3 is less than
Or equal to
y.
is less than a positive infinity.
Okay. Everybody agree? Is that a good range? Because the lowest point on the graph has a y value of -3. Can we ever get to the highest one? Nope, so that's positive infinity. Good job. Okay, remember I said when we practiced that the other day, so we're going to be using this. Okay, anybody get questions about this graphing and identifying domain, range, what kind of graph it should be? I think we're pretty clear. Okay, then let's go down and do one more thing that you're going to do in your homework. It says finding values using graphs. In other words, they want you to graph it, and then they're going to give you an x value that you did not use in the table, and they want you to use the graph, not algebra, not substituting it in. They want you to use the graph to get your y value. So we're going to look for when we need to find the value of y when x equals 3, but we're not going to do it in the table. Notice I picked some values for you again. And it says use the graph to do that. Well, we got to get a graph, don't we? So we're going to substitute into our function rule the 3 numbers I did choose for you. So I chose -6. This is kind of familiar. A third of -6 is? 2 or -2? -2. Okay, so -2, take away that 2. Oh, wait a minute, -2. The temperature drops another 2 degrees. -4. And then we'll get the other 2 once you have your three ordered pairs, put them on the graph. This is actually a continuous graph. I chose x values again for you. So negative 6, 0, no, that's not right. Negative 6, negative 4. 6, 0. This is actually a continuous graph because I chose the values for you. You weren't given a distinct domain. So draw a line going through them because I think these should line up nicely on a line that you can draw through it, but do a better job than I did. And use the graph to find y when x is negative 3. Not the table, no table, no substituting in. Use the graph to find y when x equals negative 3. How are we going to do that?
You go to -3 on the x line and go down.
Okay,
Go
so,
down.
yeah. So we go to where x is equal to negative 3, we follow it down, and we say, oh, it's right here. And what's that ordered pair name right there? Negative 3, negative 3. So we're going to say when x equals negative 3, y equals negative 3. They just happen to have the same value. Doesn't mean that will always be the case, but in this case, when you go to x equals negative 3 and follow into the graph, to the line, that's what you get. Okay. Any questions about that? If you wanted to make sure it was right, we could substitute it in and see if it was. Yes, Ron?
We have to find that between the two.
Do you have to find the what? Domain and range? No, this one you don't. This is just finding the values using the graphs. Okay, we weren't really graphing except to find the value. Okay. Okay, any other concerns?